next talk will be given by Karsten Jan and Naviya Dabiru from GmbH Germany, Tata Consultancy Services. The topic is implementing a genomic data management system using iRODS at Bayer Healthcare.
Okay. Yeah, thanks for the introduction. So Naviya and me are going to tell you a bit about our project of introducing iRODS at Bayer Healthcare. Yeah, and our experiences with that and so on. So I hope it's worthwhile to learn a bit from a group of people who have not so much iRODS experience, but still, let's see, is it working? Ah, no, I can turn the slides, great. Okay. Yeah, but from our perspective of just having introduced iRODS a couple of months ago, maybe this is interesting for people who are just about to do it in their organization as well. So this is here specifically for one user group, the bioinformatics users at healthcare. So these are the guys working in target discovery who really find out how disease correlates with genomic information and phenotypic information as well. So they have their own sequencing machine now, which is producing lots of data, of course, but they also get information through collaborations, and this is really shipped as hard drives sometimes. So studies that I've seen are about 2 terabytes in size, but this may vary, and there are also lots of more to come. So they are really command line savvy. They use a high-performance compute cluster and hundreds of command line tools, because that's how bioinformaticians work. But for a couple of processes, there's a main application that we're using. This is the gene data profiler. And Mark from Gene Data in the next talk will explain about how we integrate iRODS with that application. Yeah, this amount of data, of course, we don't want to keep on the HPC for a long time. So iRODS will be the storage system for that, and users need to check in and check out. And also metadata is important to these users because this is very personal information, and there are lots of legal strings attached to that. That means that you can't even copy this outside of Germany, for example, for some studies, or you need to respect the patient consent in other forms. And this is why we need access group membership for all the studies, and also need to find out, for example, which patient belongs to which file and these kind of questions. So iRODS is really addressing these needs, and almost all of them. With the iDrop interface, there's something that we would like to have some improvements, but basically all the user management things, metadata features and so on are covering the requirements here. The sequencer has an automated process that data automatically gets checked into iRODS. And as in this project team, we've also worked a lot on ensuring that we can operate iRODS stable and safely. And in the implementation here, Tata was a lot of help to support us. So as I said, it's important to us that it's clear who has access for which data. So Bayer has an existing web application to manage LDAP groups. So real business users, it's not the IT guy, but real business users who are the owner of a group can manage the memberships inside the LDAP group. And this is how we put the persons who are really responsible for study in charge to define who has access in iRODS. Now, the LDAP groups are not readily available in iRODS. That's why there is a replication script that we have developed which automatically synchronizes this as iRODS groups, and it's there. Yeah, and it's also, these groups are necessary for multiple other applications outside of iRODS, because once you have defined the access rights, you can use that in different applications. Now coming to the topic of metadata, we found that there are different user groups. One group is maybe not even called a user group because they are not even iRODS users. Yeah? So some people who belong to a study can contribute metadata, for example, how the data classification is and other things. And there are also these like hardcore detail bioinformatics users who can keep track of their tool chain and versions and data provenance, how the file really got produced and things like that. That's all metadata. And we wanted to come up with a simple tool so that both groups can contribute to the metadata in iRODS. And we had a fairly low-tech solution for that. So we designed an Excel sheet. This is a simplified version here, not the real one, but basically this allows you to attach attributes here to different collections of file objects and have the values for them. And there's also some kind of validation directly inside the Excel sheet, for example, for fixed value lists and things like that. And this validation here, that's backed by another sheet, also in Excel, where we define if that attribute is mandatory or if it should contain free text or just a text from fixed list and stuff like that. So we've developed a command line tool for bringing that table here into iRODS, also recursively, for example. And but there's more work to do, for example, regarding the validation steps. Yeah? So the tool could validate this automatically, and since there can be multiple sources for metadata, it would also make sense to validate it on a periodic basis directly in iRODS. Okay. So as I said, these bioinformatic guys are the command line people. They have an high-performance compute cluster. This thing lives in its own separate network here. It has its own storage to serve the files in a parallel way to the compute nodes. So this is how genomic data processing is done a lot. And the integration with iRODS is not so easy. So there was an idea of mounting iRODS as a file system directly on the HPC, but this didn't really work out. So we thought the safest and most performant way is that there's really a node that sits in both networks and where the user can log in and transfer the file from iRODS to the HPC. Then stuff is computed there, and in the end, they can get back their results to iRODS again. Now, when you duplicate this storage there, this means that a couple of other issues arise. Yeah. So for once, this HPC file storage has its own access permissions. So now we have to kind of make sure that not more people have access on the HPC than would have access in iRODS. This is currently still a manual task, and we could automate this a bit so that access permissions are synchronized there as well. And the metadata that we can produce here, for example, with command line tools, we can just check them in immediately because the file isn't even there. First, the file has to be checked in, and then you can also get the metadata in. And since this can be a group of people working here, they also need to make sure that when they check in files, they don't overwrite the stuff of their colleague, because it's not really like a controlled version system. Yeah? So in the following 2 slides, Navia will tell a bit more about the implementation that we have here. Do you have a mic, or do you want this one? Okay. Let's see.
Hello all. So now that we have huge amounts of data within iRODS, for all the day-to-day activities which we had to perform within the organization, so we have customized few of the applications in order to make the day-to-day activities easy. So as we see in here, this is the organization structure within Bayer. We have a zone under which we have different kinds of studies. So we have clinical studies, then research studies, and also secret studies. coming from different kinds of user groups, and each study has multiple projects within, and each project has multiple kinds of data. And what we target to do is we have custom applications to handle this data in a better way. So these are few of the custom implementations that we have done. One, the first being the custom ACLs. So wherein now we have different kinds of data and different kinds of read-write groups, and it's also, there was a heavy necessity that certain part of the data within the tree structure should be only read accessible and some of it should be write accessible, and certain data should not be deleted by any set of users from any of the user groups. So we have used a certain set of rule policies, and we have implemented custom ACLs at each levels, and also a public browsing facility at the top level. Then within the entire zone, we have implemented what is known as hierarchical inheritance. So if a new set of data is added either through a console or a UI, we take care to see that within the entire tree structure, the ACL permissions are carried forward. And now that we are handling this huge amounts of data, there's heavy necessity to also have a kind of audit logging. So who is actually storing the data or checking out the data, and also what kind of ACL permissions are handled by these users, and what kinds of metadata is checked in or tagged, or what kind of metadata is being removed. So all kinds of this audit logging is also being tracked, either whether it is through a UI or a console interface. Then we also have custom tools for handling bulk meta operations. Now that we have huge amounts of data being transferred in a distributed resource environment between a set of ICAT to multiple resource servers, we had a heavy necessity to have metadata handled at a bulk level. So we were using a certain kind of API-based tools in Python, which help to store multiple set of metadata, as we have seen in the previous slides, using an Excel-based input format. To help upload multiple set of metadata, we can add data, override data, and also remove data from any of the resource servers. Then there was also a need to validate the data. Now we are tagging this data with different kinds of attributes or AVU tuplets, and now we need to validate, like certain set of metadata are mandatory and certain set of metadata are optional. So we were also developing certain kinds of custom validation reports to see that proper metadata is tagged for each set of study or each set of project within the zone. Then we also felt that now we have a lot of files stored in a distributed environment. We need to have certain kind of checksum implementation. So we have two kinds of checksum generation. One, we auto-enforce checksum for every file which is being stored into iRODS, either through the console or web UI. At the same time, we do a certain kind of data integrity or consistency, wherein we generate consistency reports on a weekly basis that help to see if the checksums are improper for all the set of files which are required, or if there's any inconsistencies at any level. So for this kind of implementation, we were using a configuration management system known as Puppet. So Puppet primarily helps to have an automated deployment of iRODS. Now it could be either on an ICAT or a resource server. All the user needs to provide, or the admin who needs to install iRODS needs to just provide whether it is an ICAT or a resource server by just configuring the parameters at the start level, and then this is handled over to Puppet. So Puppet determines the role, whether it is an ICAT or a resource server, and it also helps to choose what kind of operating system we need to have. It could be Ubuntu, or it could be CentOS or RHEL or anything. And the database type can also be configured, whether it is Postgres or MySQL. And the authentication scheme can be either IDENT, Trust, or MD5 based authentication. You could also choose which iRODS version you would like to have. And you could also have whether it's a basic authentication of users or PAM LDAP supported SSL based authentication. So here again we have different categories. One is SSL with certificates, and one is self-signed certificates. So this entire process has been automated by using this tool, and it also supports multiple environments. Now that we have different set of customers, and what we handle here is from dev to QA to prod environment, we were handling different kinds of support deployments using this custom-based tools. But we also had to keep in mind that whenever there's a version upgrade or a security upgrade to be done, we have to again further upgrade the Puppet tool itself. So the rest of it would be continued by Carsten. Yeah.
You said, is it okay? Yeah, seems so. All right, so last two slides are about some recommendations or lessons learned for us here. So I think here the most important point is to highlight that it makes sense to have your own testing for iRODS as well, because it's like your own installation and also your expectations that iRODS has to fulfill. And you can see from case to case or from to the next version if that's still fulfilled or not. Yeah, I guess I just, in the interest of time, skip a couple of points here. And the next slide is about the organizational recommendations. So this was really helpful for us to have a couple of web access with the iRODS consortium, and they were really helpful here. So it makes a lot of sense to ask them with issues you have instead of just keep trying on your own. The metadata, that's really helpful to have a concept or maybe even this Excel table so that it's clear who's what's going to be in there, who has access for what. And it's really difficult to get all the metadata from the people, and you first have to convince them. Yeah. And also when training users, we found that we have to explain them that there's something like a trash can, for example, so that the file is not gone away if you delete it immediately. And it's also, if you use replication, that the things could get out of sync and stuff like that. Okay, so now I guess we have a couple of minutes left for questions, if you have any. Yeah, so can you make a spot?
How many people do you have, did you have working to develop your iRODS infrastructure?
Yeah, so there's a project team of about 4 people now, but not all full-term, yeah. And so that's, that's about it. So I guess 4 people, 4 years, something like that, yeah. No, for 1 year, sorry, yeah. And we also did one production upgrade. So we had to prepare an upgrade from version 3 to version 4. We rolled this out a couple of weeks ago. Yeah. Okay.
So talking about the roles and who does what in the organization, when you have to, say, for instance, create a new study comes online, and you have to go in and add that to the resources, who does that in your organization?
So we want to change that. So currently this is still the IT people like us. They would initially create the study and wire this LDAP group thing to the study. But I think we can set up the user rights so that even the users can create their own studies. In principle, if they have a template for that, they can just do it as well as we can do it. Yeah. Okay. That's